Find the Maclaurins series of f of x equals log of 1 plus x. So here's our f of x then. That's ln of 1 plus x. So let's get the f dash then. Log of something goes to 1 over the something, multiplied by the something differentiated. And inside we just differentiate, we get a 1. So this is equal to then 1 plus x to the minus 1. Now f double dashed. Differentiate this. Power rule minus the something. One less power, multiplied by the something differentiated, which is 1. F of 3. Yeah, again use the power rule. Minus 2 comes down to be with the minus to make 2. 1 plus x to the 1 less, multiplied by the something differentiated. F of 4. The minus 3 comes down to be with the 2 to make minus 6. 1 plus x to the 1 less minus 4 multiplied by the something differentiated. So there's our values for f of x's then. And f dashed f of x's, there we go. Okay, so let's do the f of zeros, so to speak. So f of 0, if we look at that one here, log of 1 plus 0, log of 1 plus 0, which is log of 1, which we know is 0. F dashed of 0. Put 0 in here, you just get a 1 to a power, which is 1. F double dashed of 0. Put 0 in here. In here you just get, again, you get a 1 to a power, which is just 1 with a minus. F3. And here you put 0 in here. Again, you'll get a 1 to a power times 2. And lastly, f of 4. And you put 0 in here, again you get a 1 to a power times minus 6. So, what have we got then? We've got our log of 1 plus x, our f of x, is equal to, now the formula, f of 0, which is 0, plus f dash 0, which is here, plus 1, lot of x, plus f double dash 0, which is minus 1, times x squared over 2 factorial, plus f of 3 of 0, which is 2, times the x cubed over 3 factorial, and then we've got plus f of 4, which is minus 6 of 0, times x to the 4 over 4 factorial. And then we should be able to see the pattern emerge after that, shouldn't we, if there's a pattern, if there is indeed a pattern that emerges. So here we've just got x. This will be simplified to minus x squared over 2. And this term, the 2 will cancel from the 3 factorial to leave x cubed over 3 over 3. And then the 6, when we expand 4 factorial, the 3 and the 2 will cancel just to leave 4. So minus x to the 4 over 4 itself. And then you can see the pattern emerging now, can't we? X minus x squared over 2 plus x cubed over 3 minus x to the 4 over 4 plus dot dot dot. So what have we got? If we were writing the x to the r term, it would be x to the r over r. Now if r, so we're going to have to write a positive or a negative one, aren't we? Because it alternates in sign. Well, it would be minus 1 to the r, wouldn't it? Yeah, minus 1 to the r, that's it. Because when r is even, then this would be r plus 1. Because then that would be odd. Because when r is 2, say, we get 3, which is odd. When r is odd, like 3, we'll get 4, and that'll be a plus. So that's what we got then. There's our general term. Dot, dot, dot. And this is valid for minus 1 is less than x is less than or equal to 1.